Right then, here we are with question 6. We're getting right into the meat of the exam paper now with an integration question, which isn't actually that bad, really, if you know what to do. So let's start. Find the integral of x cubed minus 2x squared plus 3 between minus 1 and 1. Let's put to the side the 1 and minus 1 between 1 and minus 1 for now. We'll come back to that in a minute. Let's just integrate as if we were integrating generally for this x cubed plus 2x squared plus 3. So, as I'm sure you know, when you integrate any form of x variable or other variable, then what you want to do, here we go, integral of x cubed minus 2x squared plus 3, just write it up there to make it easier. Right, when you integrate those, you need to increase the power by 1, so that 3 there is going to become a 4, that 2 there is going to become a 3, and this kind of invisible x to the power of 0, that's going to become a 1 there. So after you've done that, then divide by your new power. So I hope that makes sense. So here we go, we're going to say x was 3 plus 1 is 4 over 4 minus that 2 stays there, that 2 stays there, so 2x to the power of 3 over 3, that new power, then plus 3, and then x to the 1 divided by 1 is obviously just x to the 1. I didn't even need to write the 1 in there, but I did anyway. So then that is your integrated form, if you like, and what we can then do is go back to this minus 1 and 1 and say, right, we're going to go from, if you look on the graph here, draw a line, we're going to go from here, from 1 to minus 1, about there. So we're integrating everything in between that. We're going under the line. Let me shade it in for you, this might make it a bit easier. We're going under the line, right round here. There we go. So everything under there is what we are going to get if we integrate from 1 and then take away what we get at minus 1. Right, so we'll go brackets 1, take away what you'd get at minus 1. So let's do that. Let's put that into our equation. We'll say everything that we need 1 for. So here we go. So 1 to the power of 4 over 4 minus 2 times 1 cubed, which is 2 over 3 plus 3. So that's what we get when we sub 1 in. There you go, there's 1. Right, now we want to take away, might run out of space here, but we're going to take away what we get when we put minus 1 into all that. And when you put minus 1 in there, you get 1/4, same, then plus 2/3, because minus 1 cubed is minus 1, times 2, you get plus 2 over 3, and then obviously minus 3 at the end. 3 times minus 1 is minus 3. Okay, so there you go. So then you take this one, the blue one here, what we did when we got 1, take away what we got when we had minus 1 here. Right, and I hope you can see I am going to run out of space here. Get rid of what's on the top here. Might give me some extra room to play with. So the 1/4 minus 1/4 is going to be nothing. This minus 2/3 take away 2/3 is minus 4 over 3, and 3 take away minus 3 is going to be 6. So you're going to get 6 minus 4 over 3, which is equal to 14 over 3. And that's your answer. That's the 5 marks there. Good. Right. Next question. Okay, so then find the area. Now this is nice. This actually requires you to think a little bit about it. What we found there, I hope you can see, is that shaded area under there, under that graph. Then we want to find that, take away this area here. Let me do it in blue so hopefully you can see. If we do that there, this blue triangle that I'm drawing there, we want our answer from before, take away that blue triangle. Now you know how to make a triangle. You just go base times height times half. So the area of that triangle there, that blue triangle, that is going to be 2 times by 2 times by a half. So the base is 2, the height's 2 times by a half, which of course equals 2. Then simply take what our answer from before, our area under that graph, 14 over 3, take away that 2, and you'll get 8 over 3. It's quite nice if you spot that early on, but even if you don't, hopefully you can just work it out by looking at it. If you really understand that integration is the area under the curve, then you can work out what that triangle is there, and that comes up every once in a while. Right, I'll see you on the next video.